everyone, welcome to my channel. It's Aneta here, and today I wanted to talk about shallow and deep copies in JavaScript language. Let's get started. First thing worth explaining before moving on to copies are data values in JavaScript. There are two value types, primitives and objects. Let's see how the two differ from each other. Primitives are all the data types except objects, and primitives are immutable. They are also passed by values. Non-primitive data types are only objects, like arrays, object literals, dates, etc. They are mutable and they are passed by reference. Let's see what it means that primitives are immutable. We have a variable language with a primitive value, which is a string. And let's try some method on it, for example, repeat. Our string, repeat, and the number of repetitions. And let's see how our variable looks now. Obviously, it didn't change. I know it was just an example of one method, but believe me, there is no method that can change a primitive. But if we wanted to use the changed value, we can assign it to another variable, for example, like that. Now let's see how we can mutate non-primitives. In this example, we have an array, which is a collection of strings. There are certain methods that will change the initial value of the array. Let's try push method. We have Java, so we can push script at the end of the array, in one word this time. And what we receive is a mutated array, and that proves that objects are mutable. To make a copy of a primitive value, we don't need to do much of work. Let's see how we can achieve that easily. Assigning a source variable to a new one is sufficient to make a copy of it, and will not cause any issues since primitives are immutable. But the method should be avoided for copying objects. Let's find out why. We have a variable language object and we assign it to another variable. And in result, we have two variables giving the same value. At first glance, it seems that everything is okay. But there is an issue, and let's see what's wrong. Okay, we have two variables, so we probably want to use them for two different things. We don't need two variables with the same purpose because that will be nonsense, right? For example, we want to change age in the second object into, I don't know. And let's see what is gonna happen. Well, that's very disappointing because changing one object causes the same changes on the other. This is why we should avoid that method. But I think we should also talk about how that even happened. Let's take a look at that. We were talking before about passing by value and passing by reference, but I didn't explain what it means. Okay, so from the beginning. In a computer memory, there are two spaces to store our data called the stack and the heap. The stack stores local primitive variables and references to objects, while the heap stores the actual objects. Primitives are passed by value, which means that whenever we create a primitive value, it is stored separately on the stack. That's why we have two JavaScript strings and there is no connection between them. Objects are passed by reference. Creating a non-primitive value creates a reference called also a pointer, which is just the address to the actual object's value. And in the result of our example, we receive two references that point to the same object. So no wonder why our changes applies to both variables. And this is also the reason why we need copies. Moving on to copies, let's start with creating a shallow copy. We have different methods we can use, and I will show you examples with two of them. We will use spread syntax and object assign methods. In this example, we have an array of numbers, and I'm gonna use spread syntax to create a copy of that object. So I am creating another variable and spreading those numbers into an empty array. They are of course now the same. So let's try with making some changes on the copy. And let's try it out. From that, we can see that making a copy solved the problem with shared references from the previous example. Now our changes apply only to the mutated object. There is no connection between them, and they are separate values in the memory. Now let's use object assign on the example that didn't work well before. We have this variable language object. Let's make a copy. And try to change age value into, I don't know, print them both out, and we receive two different objects. Those objects from the examples were just full of primitive values, and as we know, primitives are not that troublemakers like objects, so what if we had a nested object? This is a good example of nested object, an array with an object inside. I am making a copy using spread syntax, and I'm trying to change age again into 126. This change altered both of the objects because, again, they share references. There is a reason why they are called shallow copies. They are not deep copies, but just copying like the first layer of the object. But luckily, we have deep copies, a good solution for nested objects. To make a deep copy, we can use one of those methods. First is to convert object to a JSON string using JSON stringify, and then convert it back into a new object using JSON parse. But keep in mind, it will not work for objects which are not serializable, like with functions, symbols, recursive data, and many other cases. Another method is structured clone. And we can also use some third-party libraries like Lodash. Let's use the object from the previous example. First copy will be created with JSON stringify and JSON parse method. And also make a second one with a structured clone method. Now make changes on age. First will be 126 and the second will be 1. Let's print it all out, and we receive 3 different objects. Summing up, shallow copy shares references with the original object and can be used for simple, not nested objects. Deep copy doesn't share any references with the original object and can be used for nested objects. Okay, that's it for today, guys. Thank you very much for watching and see you in the next one.